Alright, so we're moving on to P3, which is about waves. Determine the amplitude of the wave by measuring it with a ruler. Okay, now it's helpful if you do like a construction line for this, right? Oh, mine's a bit wobbly, sorry, it's trying to draw this on a computer. Okay, so if you put the equilibrium position in, okay, then the amplitude is defined as from the equilibrium position either to a peak or to a trough. If you measure that carefully, okay, that's 1.0 centimeters, right? And then the wavelength of the wave by measuring it with a ruler. Again, your construction line is going to be helpful for you here because it's one complete wavelength, right? Which is, you know, up to a peak, down to a trough, and then back to the equilibrium position. You can also measure it between two peaks, okay, or you could also measure it between two troughs. Okay, it's the distance for one complete cycle of a wave. All right, so that's 4.5 centimeters. Microwaves are part of the electromagnetic spectrum. Okay, and name a part of the electromagnetic spectrum that's got a lower frequency than what microwaves. Okay, so if you think about the electromagnetic spectrum, we've got gamma, then we've got X-rays, then we've got ultraviolet, then we've got visible light, then we've got infrared, okay, and then we've got microwaves, and then we've got radio waves. Okay, and that's the one that we want. Radio waves have got a lower frequency. They've got the lowest frequency of all of the 7 parts of the electromagnetic spectrum. They travel at a speed of 3 times 10 to the 8 in air, which shouldn't come as a surprise because that's the speed of light, and all parts of the electromagnetic spectrum travel at the speed of light. It's got a wavelength of 2.7 centimeters, so it's asking us to calculate the frequency, right? So we've got, gives us speed, which is v, okay? So this is the formula that we need, v equals f lambda, right? That's how we, those three things are related via that formula. So again, like you can substitute first, or you can rearrange first. Okay, I'm going to use the formula triangle to help me to rearrange. So I'm going to cover up f with my thumb. All right, and I can see that f is equal to v over lambda. Okay, so 3 times 10 to the 8 on the top. Okay, and I'm going to divide by 2.7. Or am I? Because look, it's in centimeters. Okay, now there's 100 centimeters in a meter. Okay, so to turn that into centimeters, I need to divide by 100. Or you can write that as times by 10 to the minus 2. Up to you. You can either write it as 0.027 or 2.7 times 10 to the minus 2. Tap all of that into your calculator, and that should get you 1.11111111 blah 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 times by 10 to the power of 10. Okay, and that's not our best answer. Okay, because again, we're looking back, how many significant figures there, how many significant figures there. So our best answer would be 1.1, so giving our answer to the same number of significant figures as the input data, times by 10 to the 10 hertz.